So let's just start off by doing problem 5.79, which the circuit looks like this. I have a circuit. It's a 1 ohm followed by a 2 ohm, a dependent source 2VA, 8 ohms. This is VA, 9 volts, a dependent current source, 3IA. This is a 5. This is a 2. This is a 4. And this is a 2 amps. And current here is IA. The question is, find V out using Thevenin. Right? All right, how do we do this? How do we do like Thevenin? Well, we have like a few steps we'll have to go through. The first step is to determine the load. What is the load here? The 2, because that's the voltage that we want to find. So this element over here is my load. Since we want to find like Thevenin equivalent, what is the second step? We have to find V open circuit, or V Thevenin. And the idea is that I have to remove the load, leave those terminals open, and find voltage across it, right? So the second step is to find the open circuit. So my circuit would look like this. I have a 1 ohm. I have a 2 ohm. I have 2VA. 8. This is VA. This is 9 volts. This is 3IA. This is a 5. This is a 4. And this is 2 amps. And the idea is that I have to remove the load, leave it open, find the open circuit. Right? Do you agree this is my circuit? I have to remove the load, leave it open, the rest of the circuit remains unchanged. Right? Nothing's changed. So the idea is that I have to find the open circuit. Well, let's do mesh analysis. Right? Let's do mesh analysis. So I have I1, I2, I3. Do I need an I4? No, because for V open circuit, I know it's open, so there is no current going through it. So if I call it I4, I4 must be 0. So I might as well just like ignore it. Right? Looking at this circuit, I'm claiming I know exactly what I2 is. What is I2? Remember, current sources, when we're doing mesh analysis, are either very easy or problematic. They're easy if the current source is located in one loop. They're problematic if they're located between 2 loops. What was the idea to get rid of the current source in the 2 loops? Doing a super loop. In this case, if I look at I2, that's exactly that 2 amps. So that's the easy current source. So I know I2 is 2 amps. I'm also claiming I know exactly what I3 is. What is I3? It's -3 times IA. Remember, dependent sources We still treat him just like an independent source. The only thing that changes is that its value is being controlled by something else in the circuit. So over here, again, I3 is exactly -3 times IA. But if you look at this equation, this IA is an unwanted variable. The variables that we're trying to solve for is I1, I2, and I3, right? So that IA is something unwanted. And as soon as I see something unwanted, I have to write it in terms of the variables that I care about, the variables I'm trying to solve for. So I have to write IA in terms of I1, I2, and I3. But I know exactly like what IA is. IA is this current going up. Therefore, IA must be I2 minus I1. Right? So I3 equals -3 times I2 minus I1. Now, if I look at this equation is in terms of I1, I2, and I3. So I know exactly what they are. So that's good. Right? Can I write a KVL for loop 1? I can, right? There's nothing in there that's preventing me from writing a KVL. So KVL for loop 1. Let's start here. I have 1 times I1 plus 2 times I1 plus 2 times VA plus VA. That must be 0. Right? Voltage across this 8 is VA. That's what we called it. Right? What does it tell me? It tells me 3 times I1 plus 3 times VA, that is 0. Or I1 is negative VA. Right? Again, I have an equation in terms of an unwanted variable. VA is not the variable I care about. The variables I care about are I1, I2, and I3. So I have to write VA in terms of those variables. But what is VA? VA is voltage across this 8 resistor. So what is it then? What is the voltage across the resistor? The value of the resistor times current through it. The value of the resistor is 8. What is current through it? It's I1 minus I3. Right? So it's -8 times I1 minus I3. Look what I have. I have 3 equations, 3 unknowns. Well, basically, I have 2 equations and 2 unknown because I already know like I2, right? I can plug it in there, right? So I can solve for I1, I2, and I3. We can solve for I1, I2, and I3. And as soon as I have I1, I2, and I3, I know everything in this circuit. I can answer any question in this circuit. Right? So how do I find this V open circuit? I just need to write a KVL. So if I write a KVL here, I can find V open circuit. So the KVL here tells me, let's start here. I have -9 minus VA plus 5 times current through this, which is negative I2, plus V open circuit, that must be 0. Right? But I already know VA. What is VA? VA is 8 times I1 minus I3. Right? Now I have an equation in terms of I1, I2, and I3. I can compute V open circuit. Right? And compute V open circuit. Right? So I have V Thevenin. What is the next step? Is to find R Thevenin. The third step is to find R Thevenin. How do we do this? We're going to look at our load, which is this guy. And whatever is outside this box is my black box. So I'll take a look at the black box. If there is no dependent source in it, I can find R Thevenin by zeroing out all independent sources. But that's not the case over here. Because as soon as I look at the black box, I have a few dependent sources. So to find R Thevenin, I have to find I short circuit. I already found V open circuit. So if I divide them up, I get R Thevenin. Right? That's the second case that we had. So let's do that. So third step is to find R Thevenin. But to find R Thevenin, we need to find I short circuit. How do we find I short circuit? Again, we're going to remove the load. Between those two terminals, we're going to put a wire. On whatever current we have going through it, that is our I short circuit. So the circuit would look like this. 1 ohm, 2 ohm, 2 VA. This is IA. It's an 8. This is VA. 9 volts. This is a 3 IA. This is a 5. This is a 4. So 2 amps. And this is where my load is. I basically short it out, and I find I short circuit. Right? Yes. Sure. Yeah. Yes. Right? Let's do another mesh analysis. Right? So let's call this I1. This over here, I2, I3, and I4. I'm claiming if I know I1, I2, I3, and I4, I know exactly what I short circuit is. What is it? That's I4. So we know I short circuit is I4. So I have to solve for I1, I2, I3, and I4, right? Again, all these directions that I chose here, it's completely up to me, right? I could have considered all counterclockwise. Some of them clockwise, some of them counterclockwise. So the directions are completely up to me. But as soon as I made up my mind, I have to basically stick to it. I cannot change my mind in the middle of my analysis. Keep that in mind. That's very, very important. Right? Now the rest is just very simple. I can write a KVL for loop 1. Can I? I can. There's nothing going on in loop 1. So KVL for loop 1. I have 1 times I1 plus 2 times I1 plus 2 VA plus VA. That must be 0, which indicates I1 must be negative VA. Again, I came across an equation that's written in terms of an unwanted variable. So I got to write it in terms of like the variables I care about. So I got to write it in terms of I1, I2, I3, and I4. What is VA though? VA is voltage across that 8 ohms resistance, right? Therefore, I have Ohm's law, right? What is VA? It is the value of the resistance, 8, times current through it, which is I1 minus I3, right? Now I have one equation that is written in terms of I1, I2, and I3, right? So we're good. How about KVL for loop 2? What do we know? What do we know in loop 2? We know exactly like what I2 is, because we have a current source that's located in only one loop. That's the easy case. So I2 is exactly 2 amps. How about KVL for loop 3? Can I write a KVL for loop 3? We cannot, right? And the reason for it is that 3IA current source. We don't know voltage across it. And since that dependent current source is between 2 loops, that's the problematic one. What is our solution? A super loop. We got to get around it. So we're going to get around it like this. So let's call this super loop. So I can write the KVL for super loop. So let's start here. I have minus 9 plus 8 times I3 minus I1, which is over here, plus 5 times, what is current through this? What is current through this 5? It's I4 minus I2, right? And that must be 0, right? Let's call this equation 1, this equation 2, this is equation 3. As soon as I combine 2 loops, I lose information, right? What is the information I'm missing over here? Exactly, I4 minus I3 equals 3IA, right? So I have super loop information, which tells me I4 minus I3 must be 3IA. Again, I have an unwanted variable IA. I got to write it in terms of the variables I care about. What is IA? IA is current through that dependent voltage source. What is it? What is IA? That's exactly I2 minus I1. So this is 3 times I2 minus I1. And that is my 4th equation. I have 4 equations for unknowns. I can solve for I1, I2, and I3, and I4. We can solve for I1, I2, I3, and I4. As soon as I solve for I1 through I4, what is my I short circuit? That's I4. Therefore, what is my R Thevenin? What is R Thevenin? It's the open circuit divided by I short circuit. Right? right? Now I have this R Thevenin, I have the open circuit, I can form the Thevenin equivalent. So fourth step, form Thevenin equivalent. So what I have is the open circuit, we have our Thevenin, we're going to stick our load back in here, which is that 2. What I care about is this V out. What is V out? It's a voltage divider, right? So it's 2 divided by 2 plus R Thevenin times V open circuit. Right? Does that make sense? Is that clear to everybody? Yes? No? Let's make sure it completely makes sense. You're definitely going to get one question just like this. I'm telling you like what's going to be on the exam. There is going to be one question just like this. So let's make sure we all understand how it's done. Is that clear to everybody? Yes. This is my super loop direction. It is negative VA, correct. Correct. But I'm distributing the negative sign in there. So I have I3 minus I1. Right? But yeah, you are absolutely correct. Yes. Yes. How do I find the open circuit? You mean how I wrote these equations? Is that what you mean? Yeah. So this is the open circuit, right? And since it's a voltage and I want to find it, I have to write a KVL, right? I can write a KVL in this little loop over here. But if I wrote a KVL in this little loop over here, I don't know voltage across this. So that's not a good idea. So I have to choose another loop. And again, I can write KVL in any loop I want. So instead, I'll choose like this big loop, right? Then I have negative 9 plus negative VA plus 5 times negative I2, because remember, I'm going this direction, I2 is going backwards, right? Plus VOC, that's 0. It's just the KVL in this loop. That's it. I don't know if I answer your question, because what's that? No. V open circuit, you have to like replace VA by this number. 8 times I1 minus I3. Yes. No, you already like found like I1, I2, and I3. See, you can solve for I1, I2, and I3. So you know exactly like what those numbers are, right? And as soon as you know like what those numbers are, you can plug it in this equation, right, and find the open circuit, right? Let's just say like I1 is 1, I2 is 2, I3 is like 5, for example, right? So you know all those numbers, you can plug it in here, and you can compute the open circuit. Yes. It was my choice, completely my choice. You can do like node analysis. The reason I did it, because it made my life a little easier. But if you want to do like node analysis, completely up to you.
In the exam, if let's say I do a counterclockwise, but in my mesh analysis or node analysis, I put a wrong sign per se, and then it like cascades to the whole thing being wrong. We still get like partial credit for that.
Very little, because it just shows me you don't know how to write KVL, right? But you still get like partial credit, yes. Yeah. Again, do not really worry about like the grade at the moment. I'll be generous, I promise. just think about like how you can like get the best grade you can possibly get. Okay, just focus on like learning at the moment. We can discuss the grade after you took the exam. Okay. All right, so I have like the open circuit. I have R-Thevenin. I know exactly what my circuit looks like, right? Right? So here's the question. What if I told you, given this Thevenin, given a Norton equivalent, how would you do that? I know you already computed like I short circuit and you can have like Norton. Let's forget about it for a second. Let's just say in like one example, you were only able to get this, the open circuit. And you basically found this Thevenin equivalent. And I asked you, given this Thevenin equivalent, find Norton equivalent. How would you do that? Yes, absolutely. One way of doing it is just to go back and find I short circuit and blah, 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 which given like the amount of time we have on exam, it's not a very good choice. But we know source transformation. We know as soon as we have a voltage source in series with a resistor, I can replace that by a current source in parallel with the exact same value of the resistor. So let me quickly review that. Source transformation. So I know if I have a circuit, V and R, I can replace this by a source with a current source and a resistor. All I have to do is to compute the value of the source, value of the current source, and value of the R. So what is the value of this resistor given this circuit? It's exactly the same. It doesn't change. So the value over here is R. How about the I here? That's V over R. And I can do the inverse of this. Basically, if I'm given a circuit with a current source followed by a resistor R, I can replace this by a circuit with a voltage source followed by a resistor. All I have to do is to evaluate like these things, right? What is the value of the R here? Value of the resistor? It's R. It doesn't change, right? How about the value of the source? It's Ri, right? So if you're given this circuit and you were told what is the Norton equivalent, how would you do it? We're going to do like source transformation. The value of the source is V open circuit times divided by R-Thevenin, right? What is the value of the resistor for the equivalent? Should be the same, right? And if you remember when we're doing like Thevenin and Norton, the third step was finding R-Thevenin, and we said R-Thevenin for both Thevenin equivalent and the Norton equivalent are exactly the same, and that was the reason, right? How do we get like these equivalents? How do we get like from here to here or here to here? How do we get it? Well, we determine these numbers, for example, V equals Ri and R, such that the external behavior of this circuit remains exactly the same as this circuit, right? That was the definition of equivalence, right? And that's how we actually found those numbers, right? Any question on this before I ask you another question? Is that clear what's going on here? Yes? Is the source transformation clear? Yes? Okay, perfect. What if I removed like this load in this circuit, right? What if I removed it? And I told you to determine the value of the load such that it has like the maximum power. How would you do that? Basically, my question is as follows. Let's just say I have like a circuit that is connected to some load. And the question is, determine RL such that it has maximum power. How do I do this? Yes, exactly. So if I remove this load over here and I replace it by some resistor, and I told you to determine the value of that resistor such that it has like the maximum power, what I'm basically asking you to do is to find R Thevenin. So you have to find V open circuit, you have to find R short circuit, and you have to divide them, given the fact that this circuit has a lot of dependent sources, right? If it doesn't have like dependent sources and it only has independent sources, how do we do this? We just zero out the sources, right? If you have like a current source, we open it. If you have a voltage source, we're shorting it out. And we find the equivalent resistance, right? So this question is exactly the same as me and asking you, what is R Thevenin? Because we know RL must be R Thevenin to get maximum power, right? And the reason for it was, we know if we have a circuit, doesn't matter how complicated it is, we can replace this circuit by a circuit that looks like this. And we put the load back in here. Basically, the circuit can be replaced by this portion, right? And in this circuit, we know exactly how to determine RL such that it has the maximum power, right? RL must be R Thevenin, right? So if I give you like a circuit and I tell you, give me like the value of RL such that it has the maximum power, you're going to treat that element, that RL, as your load, which is your load, and then you're going to find the equivalent resistance, either using V over I or just zeroing out the source, right? Any question? Yes. Sure. Do you say 179? I can't do like this problem, right? I cannot do this. No, because we have like dependent sources, right? Because like this problem, this is my black box. And in my black box, I have dependent sources. I can only zero out the sources if I only have independent sources. So I cannot do it for this problem, right? Any other question? If you don't have any question, let me quickly talk about another problem that I actually sent out an announcement for it. Problem 5.94, right? So let's quickly take a look at this problem. So problem 5.94. The circuit looks like this. This is VA. This is 2 times VA. This is 6. This is 7. This is AB. This is a 5. This is a 9. And 4 times IA, which I know IA is. Right? Let's look at the circuit and understand a few different things. First of all, we talked about linear circuits. And we said whatever circuit we're dealing with is linear, which means this circuit is linear. Right? What is the definition of like a linearity? Like one part of linearity is homogeneity, which means if I basically multiply my input by some constant, my output will be multiplied by the exact same constant. Right? So if I multiply my input by 4, my output must be multiplied by 4. Right? So let me quickly remind you what that means. Reminder, since the circuit is linear, if input 1 results in output 1, if we define input 2 to be some alpha, some constant, times input 1, output 2 must be the same constant times output 1. Right? That's a homogeneity of a linear transformation in general. Right? So this is reminder 1. Reminder 2. Regardless of any type of like circuit, I know Ohm's law always holds. So if I want to find resistor, the value of the resistor, I can always look at the voltage across those 2 points and divide it by the current through it. It always holds. So if I want to find a resistor between these 2 points A and B, if I know voltage across these two, if I know current through it, I can always find R. So reminder 2 is that R is always V over R. Right? But looking at the circuit, there is absolutely no independent source in this circuit. What does that mean? It means I got nothing in this circuit that can supply the circuit. So if I compute anything in this circuit, that must be 0, because there's nothing to supply. So if I look at A and B and leave it open and call that the open circuit, what is the open circuit? It's 0. There's nothing to supply. This circuit has no independent source to supply. Right? So if I look at it, since there is no independent source to supply, if I look at V open circuit across A and B, that must be 0. Right? But since V is 0 does not mean if I look at this circuit from A and B, the equivalent resistance is 0. Right? So all I have to do is to stick a source, a mock source, let's just call that a 1 amp current source, right? And then try to find voltage across it. Basically voltage A to B. Now, since I have this 1 amp source, that 1 amp independent source can supply my entire circuit, and I can find voltage across A and B, and that's no longer 0. Right? So what I'm doing here is that I'm forcing this 1 amp independent source into this circuit and try to find voltage across that. And due to the linearity, if I change this value to, for example, 4, 5, 10, the output, which is voltage, is still going to be multiplied by 2, 3, and 10. So it doesn't matter. I can just like stick a 1 there because it makes my life much, much easier. Why? Because I stick that 1 there, I know R is V over I. I know I is 1, so I just need to find VAB. Therefore, my R is VAB. Right? And finding VAB is not a very difficult thing. I just need to write a bunch of like KVLs. I can do like mesh analysis. Right? So I can find VAB exactly. So if I want to draw the Thevenin equivalent, what does it look like? Well, this is my Thevenin equivalent. Why? Because I have to have V open circuit. But I know V open circuit is 0. So it's just a wire. And I have like R Thevenin. Right? So keep that in mind. The idea here is very simple. I don't have any independent source, so nothing in the circuit is being supplied. Right? Therefore, whatever I compute would be 0. And actually, if you look at this circuit, that kind of explains that as well. Why? Because let's just say I stick a load over here. Right? I know the open circuit here is 0. Right? What is current through here? I just need to write a KVL. Let's just say this is R. What is I? I is the open circuit divided by R Thevenin plus RL, which is 0. Right? So if you wanted to like start by finding like Norton equivalent, we had to like short it out. But we know there was nothing there, so that must be 0, which confirms it. Right? So the whole idea of this problem comes from the linearity of the circuit and the fact that Ohm's law always holds. Right? So if I don't have like any like independent source to supply the circuit, I can always force that into the circuit and find voltage across the exact same independent source that I forced into my circuit. Right? And then that basically V over I is always my resistor. You might ask me, why did you add an independent current source? I wanted to add an independent voltage source. Please do. You can exactly do that. And you can choose any value for it as you want. But the idea instead would be you have to find current through that source, right? Because you have to find that ratio V over I. If you stick a voltage source, you have to find current through it so you can actually like compute that ratio. Right? Yes. V Thevenin is not equal to V A and B. It's equal to V open circuit. And if you leave A and B open, in this case, if you leave A and B open, that is your V open circuit, which is V Thevenin, which is 0. Because again, there is nothing in the circuit that can supply it. So whatever I compute must be 0. Right? Does that make sense? Any question? All right, I'll see you guys Wednesday.